Hello boys and girls, in this video we will learn how to solve linear equations. What is a linear equation? Linear equation is having a variable whose power is 1. Okay, it cannot be more than 1. If it is more than 1, we will call it, say for example, if the power is 2, we will call it as a quadratic equation. Okay, so linear equation is something in which the variable power is 1. What is a variable? Anything that is not known is a variable. For example, in mathematics, we use the letters like alphabets X, Y, Z, A, B, C. Those are the letters that we use to represent unknown quantities. Okay. So, what is an example of a linear equation? For example, 3x plus 5 is equal to 0. Is this a linear equation? It is a linear equation because two things. One, there is an equal to symbol. Other one, the power of x is 1. Okay, so is this a linear equation? There is a equal to, that's fine. But the power, there are two x terms. Like here, this term also has x in it and this term also has a x in it. So what is the power of x here in this term? 1. Okay, what is the power of x here? 2. So the maximum power of x in this given equation is 2. So this is not a linear equation. Okay, that's how you have to figure it out, whether it is a linear equation or not. For example, I'm going to give, is this a linear equation? It is again not a power, it's not, this is again not a linear equation because this is the term which is having x, this is also another term having x, isn't it? What is the power of x here? 1. What is the power of x here? Minus 1. Okay, if this x goes up, it becomes 5x to the power of minus 1. Okay, so here the power of x is not 1, so that is why this is not a linear equation. This is also not a linear equation. This is the linear equation. Okay, for example, I'm going to give another one. 5 into 2x plus 5 is equal to 2 into 3x plus 7. Is this a linear equation? This is a linear equation because this is the term which is having x in it and this is also term having x in it. There are two terms, that is fine. You can simplify it while you're solving the linear equation, you can simplify it. But the maximum power of x term here also is 1 and here also 1. So it is not exceeding more than 1. So that is why this is also linear equation. To solve the linear equation, there are 3 easy steps that you can remember. Let's see what are the steps. One is expansion. Okay, I'll explain in detail. One is expansion and the second one is reorganizing the terms. Reorganizing the terms. Okay, that also I'll explain. And the third step is solve for x. Solve for variable. Solve for x or solve for variable. So the first one is an optional step. It's not necessary that you have to do it in every sum. The second one, most of the sums you have to do it. That is also not necessarily. And this is obviously, it is mandatory step. You have to do it. Let's take one example. 2 into 5x plus 3 is equal to 7x plus 9. Okay, let's see what is that first step, expansion. So where does the expansion comes here? Because there is a bracket here, we need to expand the left side portion. Okay, any equation, the thing that is on the left side is called a left hand side, the one that is on the right hand side is called a RHS, right hand side. Expansion is mandatory whenever you come across a brackets. Here we have a bracket. We need to expand it. How do we expand any bracket? So anything like this written, so you have to multiply this into this plus, if it is plus here plus, or if it is minus minus, and this into this. Okay. So this 2 is multiplying 5x and the 2 is also multiplying 3. And whatever symbol is here in between, that goes in between. Okay, so let us expand 2 into 5x, that is 2 5s are 10, 10x plus 2 3s are 6 is equal to 7x plus 9. So the first part is done. Expansion part is done. Okay. Expansion part is needed. Expansion part is done. Expansion is needed because we have a bracket here. If there is no bracket, there is no need for expansion. For example, I will give another example. 2x plus 3 is equal to 5. Is there a need for expansion here? There is no need for expansion because there is no bracket. Okay? You simply go with this step and this step. This is optional, as I said. Optional, I said, because this is needed only when you come across brackets. Otherwise, it is not needed. So, this is another example where there is no need for expansion. There is no bracket here. Okay? There are just 3 terms. This is one term, this is another term, this is another term. So, this is a constant term, this is a constant term, and this is an x term. And the power of x is 1. So, that is why it is a linear equation. Okay? Next, the first part is done. Expansion is done. Okay? In this case, we have a bracket only on the LHS side. Sometimes you see the bracket on both sides. For example, 2x, something like this, yeah. 5, 2x plus 7 is equal to 7, 3x plus 5. We have brackets here and we also have a bracket here. So you need to expand on both sides. The left hand side also you have to expand, on the right hand side also you have to expand. The same way how we did here. Okay? The expansion is mandatory. Expansion is an optional step, but we have to do expansion whenever you come across a bracket. And that expansion, depending on the bracket where you see the bracket, and that side you have to expand it. In this case, only the left side it is there, so it will be expanded on the left side. In this case, you've seen the bracket on both sides. That is why you have to expand both sides. Okay, fine. The next step, reorganizing. What does it mean? Reorganizing means that we have to reorganize the terms. Okay, what do I mean by term? See here, this is one term, this is another term, this is another term, this is another term. Okay, fine. We understand what the term is. Okay, anything that is separated by plus or minus is called. So any entities that are separated with plus or minus symbols in between is called term. So this is one term, this is another term, this is another term, this is another term. Fine, we understand what the term is. What do I mean by reorganizing those terms? So here, this is the term having x and this is the term having x. Okay, these are the two terms having variables. And we also have the terms that are constants. This is the term having a constant. This is another term that is having a constant. When I say reorganize, we have to reorganize the terms such that all x terms comes to one side, all constants goes to the other side. Which side you have to bring the x term is up to your choice. Okay, there is no clear rule that you can bring it to the any side. But when you're reorganizing, remember, when you're reorganizing, bring the terms, bring all the x terms to one side. I mean, bring all the terms that are having variables to one side. Bring all the constants to the other side. Okay? Okay, so this is the term having a variable, this is the term having variable. But while you're bringing, when you're reorganizing, you stick to the basics. What are those basics? If a plus goes to the other side of equal to, it becomes minus. If a minus goes to the other side of the is equal to symbol, it becomes plus becomes minus, minus becomes plus. Similarly, multiplication into becomes a division and division becomes a multiplication. Okay, so this is a term and this is a term. I want to bring x terms to this side. This 10x is already on the left side. I want to bring the 7x also to this side. Okay, I am doing that. 10x I left it on the left side only. 10x. On the 7x I am going to bring it to the left side. If I bring it, what is the symbol here? What is the sign here? It's a plus sign. If there is nothing, you can consider it as a plus 7x. If you bring it to the left side of the equal to symbol, this becomes a minus 7x. Do you agree? Yes. Okay. Plus, if it goes to the other side of equal to symbol, it becomes minus. On the right side, you already have 9 plus 9. Leave it on the right side. And this plus 6, if you take it to the other side, it becomes a minus 6. Okay. forgot to mention one more step in between. The step is simplify. Simplify the terms. Simplify the terms and solve for x. Okay, so now you have to simplify those terms. So you have two terms here on the left side, both are having x in it. So it's easy to simplify. Okay, say for example, if you have 4 oranges plus 5 oranges, you can easily simplify. You can easily sum them up and say 9 oranges. Okay, if you have 4 oranges plus 5 apples, you cannot simplify it. Okay, so that is why the terms having the variable you brought to the one side so that it is easy for you to simplify it. Okay, now let us do the simplification. Simplify the terms. These are two terms here and you can simplify it. 10x minus 7x is 3x. On the right side, 9 minus 6, again these two are constants. You can simplify it, isn't it? Yeah. 9 minus 6 is 3. Now you solve for x. Solve for variable. Here in this case we have x. Some equations may have a variable y. Some equations may have a variable a. Some equations may have variable z. Okay, so solve for variable. So I want to solve for x. While I am solving, again you stick to the basics. Those basics plus if it goes to the other side it becomes minus. Minus if it goes to the other side it becomes plus. Into becomes division. Division becomes multiplication. So here what are we doing here? We are multiplying 3 and x. If a 3 goes to the other side, what you need? You need the value of x. To find out the value of x, whatever the number that you are multiplying x with, that if it goes to the other side, it becomes a division. So 3, this 3, if it goes to the other side, has become divided by 3. 3 divided by 3 or 3 by 3. Either way you can write it. Okay. So if you simplify this one, we will get x is equal to 1. Okay. Okay. So this is the step where we did a reorganization. Reorg. This is what we did is simplifying. After simplifying, I mean to say, after reorganizing, we got this step. After simplifying, we got it. And this is where solve for x. Solve for x. Okay, so these are the steps that you can remember and you apply it to any linear equation. You will get the value of unknown variable. Unknown variable. Okay, so I am going to give another. We will take another example and we will follow the same 4 steps. Okay, so 4y plus 7 is equal to 8. Do we have to do any expansion here? There is no bracket, so there is no need for expansion. So you can skip that step, first step. The second one is reorganizing. You have to reorganize. So on the left side, what are the terms you have? You have the term that is having a variable and you also have a constant term. Okay, on the right side you have a constant term. Okay, so you have to reorganize such that you leave all the variable terms on one side and bring all the constants to the other side. So this is the term having a variable, you just leave it on the left side. This is a constant term, you take it to the other side. If you take plus 7 to the other side of equal symbol, it becomes minus 7. Because it is a plus 7 here, if it goes to the other side, it becomes minus 7. Okay, now simplify the terms. So what are the terms that you can simplify? These are the two terms. This is one term, this is another term. And there is a minus symbol in between. Minus sign in between. These two are terms you can simplify it. After simplifying, you will get 8 minus 7, 1. On the left side, you still have 4y as it is. Okay, we have done this step. Simplification is done. And then solve for x. In this case, there is no x. Why? Because we framed the equation with a variable y. Okay, so instead of x, I will say variable. Solve for variable. That makes more sense, isn't it? Solve for variable. So if I solve for y, here it becomes 4. If it goes to the other side, it becomes a division. That is by 4. Y is equal to 1 by 4. So this is answer. Okay, so in this sum, you don't have to apply this one, but this one, you have to apply it. Okay, you have to apply it. Okay, let's take one more sum. Okay, let's do that. Yeah, so is there any need for expansion? There is no need for expansion because there is no bracket. The second step, reorganizing the terms. So what are the terms? This is one term, this is the other. This is term having x and this is term having x. You bring it to the one side. Either side is fine, but while you're changing their sides, you stick to the basics. Okay, so I'm going to bring 5x to this side. If I bring 5x to this side, it becomes minus 5x because here it is a plus 5x. Okay. Okay, so that is why if it goes to the other side of equal to symbol, it becomes minus 5x. On the right side, you have minus 8 here, this minus 8, this plus 5, if it goes to the other side, it becomes minus 5. Okay, plus 5, if it goes to the other side, it becomes minus 5. Let us, this part is done. We reorganized. Reorganized such that we have all the terms having a variable on one side and we have all the terms that are having constants on the other side. Now you simplify these terms. So these are the two terms having x. You can simplify it. 2x minus 5x is minus 3x. Okay, 2 minus 5 is minus 3 and the x. 8 minus 5 is minus 13. Okay, this simplified the terms. We simplified this one and we got minus 13, and so we simplified this and this, we got minus 3x. Solve for variable. What is variable? X is a variable here. Minus 13 on the right side. If you take minus 3 to the other side, it becomes a division by, divided by. Okay, minus by minus is plus, plus by minus is minus, plus by plus is plus. Okay, if you have two same symbols on the numerator and the denominator, the result will be positive. To say whether it is positive or negative, if you have same, here also minus, you get positive number. So if you simplify it, it becomes minus and minus. Minus by minus is plus, plus 13 by 3, and if you put it in, mixed fraction, you will get 4 1 by 3. So that is the answer. Okay, so this is a sum where we have to apply this step, this step, this step. Okay, yeah, and it's also possible sometimes you may come across something like this, x by 5. I'll take another variable in this case. A by 5 minus 8 is equal to 2, or maybe I'll take 2a. Okay. Okay. Now, is there any expansion? There is no expansion. Do we need to do reorganizing the terms? Yes, we have to do. This is the term having a, and this is also having a term a. In this case, a is a variable. Bring all those terms to one side. Which side is your choice? Okay. Which side you want to do it? Your choice. So I want to take a by 5 to this side. Okay. There is no clear rule like you have to bring only the terms having variable to the left side. There is no clear rule, but your choice. But while you're doing, stick to the basics. The basics are plus if it goes to the other side, it becomes minus. Minus if it goes to the other side, it becomes plus. Okay, I want to take a by 5 to the other side. 2a. This is plus a by 5. If it goes to the other side, it becomes minus a by 5. And minus 8, we still have it on the left side. Okay. So we reorganize it such that we have all the terms having a variable on one side. We have the term having a constant on the other side. Okay, let us simplify this part. So what is an LCM here? 5 is an LCM. You can consider 2a by 1. 5 is an LCM. It goes 10a. 1 goes in 5 times. 5 into 2, 10a. Quicker. 10a minus a by 5. Okay. So here we get 10a minus a. How much do you get? 9a. 9a by 5. On the left side, you still have minus 8 as it is. Okay, there is no change. So, what did we do from this step to this step and this step? We did the simplifying the terms. We simplified these two terms. Okay, because there is a fractional involved, we got a one additional step. But this is all the part of simplification. From here to here we simplified. From here to here we further simplified. Now, solve for variable. What is the variable here? A is a variable. If you want to find out the value of A, leave this variable here. What is the one that is multiplying A? 9 by 5 is something that is multiplying A on the right side. Okay. If it goes to the other side, how does it become? By 9 by 5. Okay. 9 by 5 is something that is multiplying A. Can we write this one as 9 by 5 into A? We can write, right? Yeah. If it goes to the other side, it becomes a division. 9 by 5 is dividing minus 8 on the left side because it is multiplying on the right side. You do the simplification, further simplification. A is equal to minus 8. You can consider minus 8 by 1 by 9 by 5. Okay. So, if you have to divide, you can do a multiplication by reversing, by putting the reciprocal of the denominator. It becomes 5 by 9. Okay, the reciprocal of 9 by 5 is 5 by 9. Okay, so further simplifying, you get A is equal to minus 8 into 5 minus 40 by 9. Okay, this is the value of variable A. Okay, so this is an improper fraction. If you want to convert, you can convert it into mixed fraction. Okay, so we have pretty much seen the linear equation that is having a brackets in it, in which case you have to do the expansion, the first step, and the remaining all kind of problems you have to follow this step and this step. Okay, the first step is an optional and it is needed only when you see brackets on either side. The other steps are pretty much needed in every sum, in every linear equation, in solving every linear equation. Okay, so this is all we did, reorganizing the terms, and this is all we did solving for variable. Sorry, reorganizing is this is the part where we reorganized the second part, and this is the part where we did simplification. This is third part, this is second part, and this is the part where we solved for variable, fourth part. Reorganizing, simplifying, and solve for variable. Okay, yeah, that's pretty much it. Expansion, reorganizing the terms, simplifying the terms, solve for variable. Let's do one word problem. Okay, the problem goes like this. I have a rectangle whose length is 20% more than breadth. Okay, there is a rectangle whose length is 20% more than breadth. Okay, I'll write it. The perimeter of a rectangle whose length is 20% more than its breadth. Okay, whose length is 20% more than its breadth. The perimeter of rectangle whose length is 20% more than its breadth is 32 meters. Find its length and breadth. Find its length and breadth. Okay, I have a rectangle whose length is 20% more than of its breadth, and the perimeter is 32 meters. Find its length and breadth. Okay, so problem is given like this. So the length is 20% more. So in this case, you can consider breadth as some unknown quantity. Okay, say for example x or y or a or b, whatever is your choice. Okay, consider breadth as x. Breadth as x. How much would be the length? If it is 20% more, how much would be the length? Okay, if it is 20% more, what is 20% of x? 20 by 100 into x, isn't it? 20 by 100 into x. I'll write it bigger. If I simplify this one, I'll get this one goes 2 by 10 becomes 0.2x. 0.2x. 20% of x is 0.2x. I said length is 20% more. The breadth is already x. 20% more than of its breadth. If I add this one, this is 20% of x. If I add this one to breadth, how much would I get? So if I add this one to x, that is x plus 0.2x becomes x plus 0.2x becomes 1.2x. Okay, these two are the terms having x in it. So in such case, whatever is the coefficient here, the coefficient of x here is 1, or the multiplier of x is 1. You just simply add this and put an x next to it. That's it. For example, I say 4 oranges plus 5 oranges. What do? You add 4 and 5, 9, and whatever is the thing under consideration, you keep it next. Oranges, 9 oranges. The same way, you have 1x plus 0.2x. You add 1 and 0.2. If you add 1 and 0.2, you will get 1.2, and you keep a x next to it. Okay, it's as simple as that. Now the length is going to be 1.2x. Okay, how we got 1.2x? This is hard. This is 20% of x, 0.2x. If I add 0.2x to x, I'll get 1.2x. Okay, yeah, that's how simply you should be able to tell. Say for example, what is 10% more than of x? 1.1x. 35% of x, 35% more than of x. Okay, 35% more of x is going to become 1.35x. Okay, 20% less of x, it's going to become 0.8x. Again, 1 minus 0.2x, which will be 0.8x. Okay, 35% less of x, it's going to become 0.65x. So like that, you can use this method to find out if it is something like this is given, whose length is 20% more, or 20% more of x, or 20% less of x, 30% more of x, or 35% more of x, or 15% less of x, such things. Okay, alright, yeah. So now we have a breadth and length. So that's fine, you have a breadth and length, but this is not going to give you the length and breadth. We need to find out the actual values of x, actual value of breadth and length. To find out what is the other condition given, the perimeter of rectangle is 32 meters. So this is another data given. Using this data, you have to formulate an equation. Okay, what is that equation? The perimeter of rectangle is the formula for the perimeter of rectangle is 2 into length plus breadth. Okay, perimeter is equal to 2 into length plus breadth. What is length here? 1.2x. What is breadth here? Plus, what is the breadth here? X. What is perimeter here? Perimeter that is given is 32 meters. Okay. Yeah, you can leave those meters for now, or if you want to continue units also, that is fine, you can continue, there is no problem. Okay, now we have a linear equation. Is it a linear equation? Yes, it's a linear equation because we have a variable, one variable x, and we have two terms where we have x, and these two terms having a the power of variable in these two terms is 1. So that is why this qualifies as a linear equation. Let's go back to the same 4 steps. Expansion. Do we need expansion? We need expansion because we have a bracket. Okay. Other way of doing such problem is that because we have the same terms, though we have a bracket here, there's no need to go for expansion. Because these two terms into the bracket having a variable x in it. You can, instead of expanding it, you can simplify it. Even if you expand and then simplify it, you will get the same answer. Okay, if you want to stick to this one, you stick to it. There is no problem. But the other way of doing simply is because you can simply add these two terms because these two terms are having x in it. In the previous case, while we are solving these brackets, we used to give like this: 2x plus 5 is equal to 7 into 3x plus 2. Okay. In this case, we expanded because this term is having a variable and this term is a constant. That is why we have to do expansion. In this case, it is not needed. But even if you do it, you will get the same thing. In this case, the expansion is mandatory because this is the term having a variable and this is the term having a constant. That is why you have to expand it. Similarly here, this is the term having a variable and this is the term having a constant. In this case, both these terms under the bracket, within the bracket are having a variable in it. So these two terms you can simplify it easily. Okay, fine. Yeah, let's do the simplification. 1.2x plus x. Again, same thing. You add this one and the multiplier of x. What is x multiplier of x? 1. 1 plus 1 by 2 is 2.2. 1.2 plus 1. 1.2 plus 1 is 2.2. And you put a variable here, 2.2x. Okay. This one plus this one, 2.2, and the variable here is x. Now you can do the multiplication. 2 into 2.2x, that is 4.4x. 4.4x on the right side. On the left side, 32 will continue. So if you, okay. So what did we do? We reorganized. Expansion, as such, there is no need because the terms within the bracket are having a variable. That's not needed. Reorganizing the terms. Is there any need for reorganizing the terms? There is no need again reorganizing the terms because all along we have the variables. We have the terms having a variable on the right side. We have the constant term on the left side. Okay. Don't think this is a constant. Okay. Don't think 2.2 is the constant because 2.2 is the multiplier for x. A term is something that is isolated with the plus or minus symbols. This is a 2 is a constant, but this is not separated with the plus or minus. Instead, this is multiplying the whole thing here. Again, 1.2 is a constant, I agree. But this you cannot consider as a term. 1.2 is something that is multiplying x. So this is whole thing is a term that is having x in it. And this is also one term because there is a plus in between. Okay, this is also term, this is also term. This is not a term. Rather, this is something that is multiplying the right side portion. Okay. Now, so there is no reorganizing because all along we have the variable terms on the right side, the constant on the left side. Okay. simplifying these terms. So we simplified it. This one we simplified and we multiplied this one and we got this one. And then solve for the variable. The variable here is x. So 32 by 4.4. Okay, those many meters. Okay, you can use a calculator and do this using the division method. Okay, so this is what the answer is. What is this one? Is that the answer? This is not right. This is not the answer. This is not the final answer. Again, do not forget the units. X, what is x here? X is the breadth, isn't it? What are the units for breadth? Because the perimeter is given in meters, units also meters. Units are also meters. 32 by 4.4 meters. 32 by 4.4 meters. What is that? That is breadth. But what is the question? Find its length and breadth. You found out the breadth and you also need to find out the length. What is length? Length is 1.2 into x. X is this much and you multiply this one with 1.2. Okay. So the conclusion is breadth is 32 by 4.4 meters and the length is 1.2 x. What is x? 32. By 4.4 meters. Okay. Okay, breadth. Use your calculator to simplify it. Okay, simplifying is no big deal because this just on the fly I framed this question, so that is why these figures came in like this. But otherwise, if the sum, if you take it from a textbook, these are something that can be easily simplifiable. Okay, so the breadth is 32 by 4.4 meters and the length is 1.2 into 32 by 4.4. You can simplify it using your calculator and that is the answer. That is the final answer because the question that is asked is you need to find out the length and the breadth. Okay. Yeah, like this many number of questions, many questions can be formed. Say for example, I have some money and you have 20% more than what I have and the total sum of money is so and so. What is the money that I have? What is the money that you have? Okay. So those kind of questions. Any such sums, there will only be any such word problems, you will only come across a plus here. Okay. See, this is one example. This becomes a linear equation. This becomes a linear equation eventually because we have a plus here. Okay, when do we come across plus? Only in the perimeter case we come across a plus. If it is area, it becomes a multiplication. So it becomes a quadratic equation. Okay. Again, I'm saying again, because this is a perimeter and we have a plus here, this eventually turn out as a linear equation. Okay. Any linear equation word problems usually is always having a plus in it. It's always having a plus in it because that is where the power will not increase. Say 1.2x plus x became 2.2x. If you multiply those two, it becomes x square. That is why there is always a plus in a word problems. Okay. So the perimeter is the one where the length and breadth will not be multiplied. Instead, they are added. They are added because the units are meters. Units are simply meters or centimeters. That is why they will never be multiplied. The length and breadth will never be multiplied in perimeter. They will only be added. Okay. Yeah. The other word problems, for example, I have some money and you have 30 more euros than what I have. What is the total money? Say for example, in such case, consider my money is x and your money is x plus 30. You add these two and the total sum of money is say 50 euro. What is x? So if I add x plus 30, total money, this is my money and this is your money and the total money is 50 euro. That is the statement that is given. Okay, this is my money and you have 30 more euros than what I have. Then your money will become x plus 30. The total money is 50 euro. That is the statement. That is the statement. That is the data given. Using that statement, using that given data, you can frame a linear equation. This is the linear equation. This is not the linear equation. This is not the linear equation. These are expressions. Okay, my money is x. That is an expression. Your money is x plus 30 euro. That is also an expression. I added these two and equated to 50 euro. This is the linear equation because we have equal to symbol. Again, stick to these 4 steps: expansion, reorganizing, simplifying terms, and solve for variable. Is there a need for expansion? No. Reorganizing? Yes, we have to reorganize. How should we reorganize? Here, x plus x. You take 30 to the other side. Thereby, we have all the variables having a variable on the one side, all constants on the other side. If you simplify, the next step is simplifying. If you simplify, you will get 20, and here you will get 2x. Okay, after simplifying, I got this equation. Again, solve for variable. What is the variable? Variable is x. X is equal to 20 by 2. 2 if it goes to the other side, it becomes division. That's why you will get, thereby you will get x is equal to 10. What is x? X is my money. What is your money? 10 plus 30, 40. Okay, my money is 10 euro and your money is 40 euro. The total money is 50. 10 plus 40 is 50. Isn't it? That's how you can also verify it, whether the answer that you got is correct or not. You can also put it back into the original condition and you can verify it. Okay. So wherever there is a linear equation word problems, there will only be sum. Okay, there will never be multiplication. Okay, if it becomes, see here, the sum of the money. Sorry, sum of the money. This is my money and this is your money. If I sum it, we still have x term only. Okay, this term will not become x square because x plus x is x term only, 2x. Okay, x into x is x square. Okay, yeah, the number of word problems can be solved, but whatever is the word problem, there is only either addition or subtraction. Okay, so if you add 2x plus 5x, you will get 7x. This is also an x term having x in it. If you subtract it, 2x minus 5x, we will get minus 3x. This is also x term having x power as 1. Okay, so wherever there are word problems, either there will be only addition or a subtraction. The addition here is this addition I am talking about. The addition here is this addition. Okay, so this is the fundamentals of algebra. If you learn this one, the next step is solving a quadratic equation, and the next step is solving linear equation having 2 variables in it. There will be 2 equations. Because there are 2 variables, there will be 2 equations. Okay, so these are the things that you must be thorough with, and once you are thorough with these 3 things, one is solving a linear equation, second one is solving quadratic equation, third one is solving a linear equations having 2 variables in it. Okay, yeah, these 3 most students feel difficult, but once you crack these 3 concepts, and the rest of the high school maths is quite smooth sailing for you. Okay, yeah, we'll stop it here, and in the next session we'll meet up with some other topic. Thank you. Bye.